Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So today's lecture is a continuation of our previous lecture on chemical bonding, where we look at ionic bonding. In today's lecture, we'll be looking at covalent bonding. So the lesson objectives are, at the end of today's lecture, students should be able to define covalent bonding as the electrostatic attraction between the nuclei of two atoms and the shared pair of electrons. Also describe covalent bonding in molecules, including hydrogen, oxygen, nitrogen, hydrogen chloride, carbon monoxide, ammonia, methane, ethane, ethane, using the dot and cross diagram, and also state the properties of covalent compounds. So please, I want us to listen attentively and get the best out of today's lecture. So we are looking at covalent bonding. We say covalent bonding is when a pair of electrons are shared between two or more non-metals. So in covalent bonding, it has to do with sharing of electrons between non-metals. I told you that the essence of bonding is for each of the atoms to attain their noble gas configuration, to attain the octet or the duplex state. Every other element, they want to attain the noble gas configuration. They want to be like the noble gas. They want to attain their octet or what duplex state. So in this type of bonding, electrons are not transferred. Ions are not formed as metals are not involved. So it has to do with non-metals. When you talk about ionic bonding, it has to do with transfer of electron from a metal to a non-metal. But in covalent bonding, we are talking about sharing of electrons between non-metals so that each of the atoms will attain their noble gas configuration. Now, atoms are held because their nuclei are attracted to the shared pair of electrons. So if you look at what we have here, you see that there's a shared pair of electrons here, and both electrons are negatively charged. So what happened is that the electrons are held because the nuclei of each of the atom are attracted to the shared electron. So if you look at the positive nucleus attract shared pair, the nucleus of other atom is also attracted to the shared pair. So what keeps the shared pair of electron in position? It has to do with the positive nucleus from each of the atoms. So generally, when we talk about covalent bonding, it has to do with sharing of electrons between non-metals. So when they share electrons, they attain their noble gas configuration. So it's as simple as A, B, C. So you want to look at how we can use the dot and cross diagram to represent covalent molecules. Dot and cross diagram for covalent bonding, which looks very different from that of ionic bonding. We've done that of ionic bond whereby you use dot and cross diagram to represent the formation of ionic bond. Here we want to use dot and cross diagram to represent the formation of covalent bond. When two or more non-metals come together, when they share the electron, they attain their noble gas configuration. So the compound that is formed is what we call covalent compound. And covalent compounds, they exist as molecules. So in formation of covalent bonding, it has to do with, it can be atoms of the same elements like nitrogen, chlorine, hydrogen, etc. It can be between atoms of different elements. You have carbon dioxide, you have ammonia, you have methane, and the rest. So we want to look at the use of dot and cross diagram. So the formation can be between atoms of the same elements and can be between atoms of different elements. So it's very, very important, the use of dot and cross diagram to represent formation of covalent bond. So we want to make use of the dot and cross diagram to show the formation of covalent bond in hydrogen molecule. Now, in the formation of hydrogen molecule, one atom of hydrogen plus another atom of hydrogen combine to give you a molecule of hydrogen. Now, with the use of dot and cross diagram, hydrogen have one electron in the atom shell. This is cross. The other hydrogen will come with its own one dots. So each of them, contributes one electron for the bond formation. So you have hydrogen single bond hydrogen. Now the single bond is an indication that each of the hydrogen atom contributes one electron for the bond formation. So with the use of dot and cross diagram. Then it can also be represented in this format. You draw a circle. This is hydrogen, bringing a cross. Then the other hydrogen overlap with the other hydrogen, bringing a dot. So you see that each of them contribute one electron for the bond formation to give you the hydrogen molecule. So it is hydrogen single bond hydrogen. So this is formation of hydrogen molecule with the use of dot and cross diagram. The single bond is an indication that each of the atom contribute one electron for the bond formation, and this is what we call single covalent bond. in single covalent bond, what happens is that what each of the atom contributes one electron for the bond formation. So they share electrons. So you can see this hydrogen has completed this duplex state, and this hydrogen has completed this one duplex state. So it can be written in this format, or it can be written in this format. So it's as simple as A, B, C. So I want to use the dot and cross diagram to represent the formation of covalent bond in a chlorine molecule. In the formation of a chlorine molecule, one atom of chlorine combine with another atom of chlorine to form a molecule of chlorine. A molecule of what? Chlorine. Chlorine, the atomic number of chlorine is 17, I mean to say. That means chlorine has 7 electrons in its outermost shell, so it needs 1 electron to complete its octet state. And I say the essence of bonding, the reason why bonding takes place is for each of the atoms to attain their noble gas configuration. Every atom wants to attain the noble gas configuration, and they can do this either by sharing electrons or transfer of electrons from one atom to another atom. So we're dealing with covalent bonds. So this has to do with sharing of electrons between what? Between atoms. So chlorine has 7 electrons in the outermost shell, and each chlorine atom needs 1 electron to complete its octet state. So let's describe the formation of what? The covalent bond in a chlorine molecule. This is 1, 2, 3, 4, 5, 6, and what? 7. Then the other chlorine atom has 7 electrons. 1, 2, we are using dot, 3, 4, 5, 6, 7. So you can see each of the chlorine atom contributes what? 1 electron. So you can see this chlorine atom has attained the noble gas configuration, completed its octet state 1, 2, 3, 4, 5, 6, 7, 8. This one has completed 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, each of the chlorine atom contributes 1 electron for the bond formation. So if we are to represent it using the display formula where we show the bond, it's going to be Cl single bond Cl. So the single bond is an indication that each of the chlorine atom contributes what? 1 electron for its formation. So this is an example of a single covalent bond. We can also represent it using a different format where we draw the shells. So this is chlorine, has 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, then 7. The other chlorine atom will overlap with the other chlorine atom. So you have 1, 2, we're using dot here. 1, 2, 3, 4, 3, 4, 5, 6, then 7. So you can see each of them contributes 1 electron for the bond formation. So it's a Cl single bond Cl. So the single bond is an indication that what? Each of the chlorine atom contributes 1 electron for the bond formation. So this is a typical example of what? A single covalent bond. So the diagram represents the formation of covalent bond in a chlorine molecule. So I want to show the formation of ammonia molecule. Ammonia is a covalent molecule, so we want to show the formation of covalent bond in ammonia molecule using the dot and cross diagram. Now if you look at ammonia, ammonia contains 1 atom of nitrogen and 3 atoms of hydrogen. So formation of covalent bond in ammonia molecule has to do with what? Atoms of different elements. So that is formation of covalent bond between atoms of different elements. So this is the formula for ammonia. So we have to write the dot and cross. This ammonia, which is NH3, contains 1 atom of nitrogen and 3 atoms of hydrogen. So if we are to draw the dot and cross, this is nitrogen, have 5 electrons in the outermost shell. So we have 1, 2, 3, 4, and 5. So hydrogen will share 1 with nitrogen. Hydrogen will pair up, share 1 electron with nitrogen. Hydrogen will pair up, share 1 electron with nitrogen. So if you look at each of the atoms has attained its noble gas configuration. Nitrogen has completed the octet state. You have a dot and cross, which is 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen has completed the duplet 1, 2, 1, 2, 1, 2. So if you have to draw the display formula, you have nitrogen single bond hydrogen, single bond hydrogen, then single bond hydrogen. Then you have the lone pair here. You can use X to represent the lone pair, or I use dot to represent the lone pair. Another way we can represent it is we can represent it using the shares. So let me draw the share. This is nitrogen, which is the central atom. Have 5 electrons, 1, 2, 3, 4, and 5. So hydrogen will share with nitrogen by using the dot and cross. Hydrogen will share with nitrogen using the dot and cross. Hydrogen will share with nitrogen using the dot and cross. So each of the atoms has attained its noble gas configuration. Nitrogen has completed its octet state 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen has completed its duplex state 1, 2, 1, 2, 1, 2. So it's as simple as ABC. So this is how you show the formation of covalent bond in an ammonia molecule using the dot and cross diagram. So we also want to look at the formation of covalent bond in a water molecule. Water is a covalent compound. So we want to look at the formation of covalent bond using dot and cross diagram in water molecule. So the formation of covalent bond in water molecule has to do with formation of covalent bond between atoms of different elements. So this is water, which is H2O. Water contains 2 atoms of hydrogen and 1 atom of oxygen. So it has to do with formation of covalent bond between atoms of different elements. So let's see how we use dot and cross diagram to indicate covalent bonding in water molecules. So this is oxygen. Oxygen has 6 electrons in the outermost shell. So we'll have 1, 2, 3, 4, then 5, and 6. So water will come and share. Use the dot to represent hydrogen. Hydrogen will share. Use dot to represent hydrogen. So you can see each of the atoms has attained its noble gas configuration. Hydrogen has attained its duplex state 1, 2. Hydrogen has attained duplex state 1, 2. Oxygen has attained its octet state 1, 2, 3, 4, 5, 6, 7, 8. So if I were to draw the display formula, it would look like this is single bond, oxygen single bond hydrogen, oxygen single bond hydrogen. So we'll have 2 lone pair. I can use dot or cross to represent the lone pair. So this is the display formula. So you can say it has to do with single covalent bond because each of the atoms contributes 1 electron for the bond formation. We can also use the shares to represent the dot and cross diagram in water molecule. So let's draw it using the shares. This is oxygen. Oxygen has 6 electrons in the atom share. So we'll have 1, 2, 3, 4, then 5, 6. Hydrogen will now pair up with oxygen. We are using the dot for hydrogen. Now pair up with oxygen. Hydrogen will now pair up with oxygen. So you can see that each of the atoms has attained its octet or duplex state. So we can use this form or we can use this method, irrespective of the form. I told you the essence of bond is for them to attain their octet and duplex state to attain the noble gas configuration. So oxygen has completed 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen has completed. So each of them have attained their noble gas configuration, completed their octet and duplex state. So this is the formation of what? Covalent bond in water molecule using the dot and cross diagram. So we just want to show the formation of covalent bond in a methane molecule using the dot and cross diagram. A methane molecule is CH4. The formula of methane is CH4. That means a methane molecule contains 4 atoms of hydrogen and 1 atom of carbon. That is formation of covalent bond between atoms of different elements. So this is methane, which is CH4. So we have 1 atom of carbon and 4 atoms of hydrogen. So let's show the formation of covalent bond using the dot and the cross diagram. So this is carbon. Carbon have 4 electrons in the outermost shell. 1, 2, 3, 4. It will now pair up with 1 atom of hydrogen. So hydrogen will use the dot to represent hydrogen. Hydrogen will pair up with carbon here. Hydrogen will use this 1 electron to share with carbon. Hydrogen will pair up with carbon here. So each of them contribute 1 electron for the bond formation. Carbon contribute 1, hydrogen contribute 1. So you can see that each of them has attained their noble gas configuration. That is the essence of bonding. Carbon has completed this 1, 2, 3, 4, 5, 6, 7, 8, which is octet state, and each of the hydrogen atom has completed 1, 2, 1, 2, which is the duplex state. So they have attained their noble gas configuration. So if we are to draw the display formula, it will be carbon single bond hydrogen, single bond hydrogen, single bond hydrogen, single bond hydrogen. So this is single covalent bond, whereby each of the atom donates 1 electron for the bond formation. So this is a typical example of what covalent bond in a methane molecule using dot and cross diagram. We may also represent it using the shell, whereby we draw the shells. It's still the same pattern, it's still the same method. So it's still the same formation of what covalent bond in a methane molecule. So let me erase this so that I will give that representation. So there'll be no space for me to give that representation. So I have to erase this. So drawing the shells, we now have carbon, which is the central atom. Carbon have 4 electrons in the atom shell. So you have 1, 2, 3, 4. So hydrogen will come with this electron to pair up with carbon using dot. Hydrogen will pair up here. We'll have the dot here. Hydrogen will pair up here. We'll have the dot here. Hydrogen will pair up here. We'll have the dot here. So you can see each of them has completed 1, 2, 3, 4, 5, 7, 8. They have attained the noble gas configuration. Carbon has completed this octet state, and each of the hydrogen atom has completed the duplex state. So you have single bond hydrogen, single bond hydrogen, single bond hydrogen, single bond hydrogen. So this is formation of covalent bond between atoms of different elements, compared to the previous one that we did that has to do with chlorine and hydrogen, which are formation of covalent bond between atoms of the same element. But this one is formation of covalent bond between atoms of different elements. So it's as simple as A, B, C. So we'll talk about covalent bonding, which has to do with the sharing of electrons between non-metals. Now, the reason why they share electrons is for each of them to complete their octet or duplex state and to attain the noble gas configuration. So we've considered the formation of covalent bond in methane using dot and cross diagram, in ammonia, in water, in hydrogen, in chlorine, and you see that during the formation process, each of the atoms attain the noble gas configuration. So atoms share electrons to complete their octet and duplex state and attain their nearest noble gas configuration. But there are exceptions to this rule. There are exceptions to this octet rule. There are exceptions to this rule. Some don't achieve an octet as they haven't enough electrons, like boron in boron trifluoride and aluminium in aluminium chloride. They are electron deficient, so they don't have enough electrons. Then atoms of elements in the third period onwards can exceed their octet because they are not restricted to 8 electrons in their outer shell, like phosphorus in phosphorus pentafluoride and sulfur in sulfur hexafluoride or sulfur hexachloride. In fact, that's what we call expanded octet or maximum. So we're going to consider those few exceptions. The few exceptions are those electrons that those atoms that are electron deficient, that they don't have, they don't have enough electrons. They're electron deficient. Then we're going to talk about atoms of elements in the third period that can exceed their octet or duplex. So these are just few exceptions that we're going to consider. So please, I want us to listen attentively and get the best. So we're looking at the dot and cross diagram of boron trifluoride molecule, which is a typical example of a molecule that deviates from the octet rule, that is short of octet. It contains boron, which is an element that is electron deficient, that doesn't have enough electron to complete the octet. So we're going to look at the dot and cross diagram. Now, the formation of covalent bond in boron trifluoride is between atoms of different elements. Atoms of different elements. So this is boron trifluoride, boron trifluoride, contain 3 atoms of fluorine and 1 atom of boron. 3 atoms of fluorine and 1 atom of boron. So we're going to draw the dot and cross diagram. So you are going to see that there's a deviation from the octet. So it's short of octet. So this is boron. Boron have 3 electrons in the atom shell, which is 1, 2, and 3. So fluorine will come with its own one. Fluorine has 7 electrons in the atom shell, so it will share electron with boron 1, 2, 3, 4, 5, 6, 7. So it will share electron. This is another fluorine atom 1, 2, 3, 4, 5, 6, 7. We are using the dot for fluorine. Fluorine, which is 1, 2, 3, 4, 5, 6, 7. So you can see that the central atom, which is boron, contain what? 6 electrons, which is short of octet. So it deviates from what? From the octet rule. And because boron is electron deficient, it's short of electrons. So this is the dot and cross diagram of boron trifluoride. So we can also use the other representation whereby we draw the shells. So I'm going to erase this, then I will use the shell to represent it. So it's still the same thing. You can still use the same pattern. So if I'm to draw the shells, so you see boron have 3 electrons in the ensemble shell, which is 1, 2, and 3. So fluorine will come with its electron share with boron. This is boron 1, 2, 3, 4, 5, 6, 7. This is fluorine sharing with boron. Another fluorine atom will come 1, 2, 3, 4, 5, 6, 7. This is another fluorine 1, 2, 3, 4, 5, 6, then 7. So 1, 2, 3, 4, 5, 6, 7. So you can see that the central atom has 1, 2, 3, 4, 5, 6 electrons, which is short of octet, deviating from what? The normal octet, configuration. So if I had to draw the display formula, it would be boron, this is fluorine, and this is fluorine. So it's as simple as ABC. You can use this method or the other method, whichever method is okay. So that is it. So it's as simple as what? ABC. So we are still on molecules that deviate from the octet rule. So we're going to look at the dot and cross diagram of phosphorus pentafluoride molecule. Formation of covalent bond in phosphorus pentafluoride molecule, whereby there is a deviation from the octet rule. In phosphorus pentafluoride molecule, we have what? More than 8, which is expanded octet or maximum. And the formation of covalent bond in phosphorus pentafluoride, it is between atoms of different elements. So this is the formula for phosphorus pentafluoride, which is phosphorus pentafluoride. So phosphorus pentafluoride molecule contains 1 atom of phosphorus and 5 atoms of fluorine. So it's as simple as ABC, 1 atom of phosphorus and 5 atoms of fluorine. So if we are to use the dot and cross diagram, phosphorus have 5 electrons in its outermost shell. So we're going to use cross to represent phosphorus, which is 1, 2, 3, 4, 5. Then it's going to share electrons with fluorine. Each atom of fluorine contains 7 electrons in its outermost shell. So we'll have 1, 2, 3, 4, 5, 6, 7. So fluorine has completed octet. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, then 7. Then this is 1, 2, 3, 4. Then 5, 6, 7. So if you look at phosphorus, this is the central atom. It has completed how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So which is expanded octet, which is more than 8. So this is an example of what? A molecule that deviates from the octet rule in the formation of what? Covalent bond. So please, I want us to take note of that. I'm going to represent it whereby I use the cycle, use the shells, So we use the shells. We are going to give another representation whereby we have to use the shells. So I'm going to erase this and draw that. So we'll draw the shells. This is phosphorus with 5 electrons in the outermost shell. 1, 2, 3, 4, and 5. So fluorine has 7 electrons. So we'll have 1, 2, 3, 4, 5, 6, 7. Then this 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Then the next 1, 2, 3, 4, 5, 6, then 7. So this is fluorine. This is fluorine. So if you look at phosphorus, let us completed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So which is expanded what? Octet or more than octet. So if we draw the display formula, it will be like this: phosphorus so the single bond, each of them contributes 1 electron for the bond formation. That's why you have the single bond. So this is an example of what? A molecule that deviates from the octet rule. In this situation, we have expanded octet, which is more than 8. So please, I want us to take note of that. So we want to look at formation of covalent bond in sulfur hexafluoride molecule. So we want to look at the dot and cross diagram of sulfur hexafluoride molecule, which is a molecule that deviates from the octet rule. So if you look at sulfur, the formation of covalent bond is between atoms of different elements. So sulfur hexafluoride contains 1 atom of sulfur and 6 atoms of fluorine. 1 atom of sulfur and 6 atoms of fluorine. So it is between atoms of different elements. So there's a deviation from the octet rule. Here we have the expanded octet or maximum, whereby the central atom contains more than 8 electrons. So it's an exception. So please, I want us to take note of that. So this is sulfur. Let's look at the dot and cross diagram. We're going to use cross to represent sulfur. Sulfur has 6 electrons in the outermost shell. So have 1, 2, 3, 4, then 5 and 6. Then fluorine, we look at fluorine. Fluorine has 7 electrons in the outermost shell. It's going to share with sulfur, which is 1, 2, 3, 4, 5, 6, then 7. Then we look at fluorine again, which is 1, 2, 3, 4, 5, 6, 7. Then we look at fluorine again, which is 1, 2, 3, 4, 5, 6, 7. Is fluorine 1, 2, 3, 4, 5, 6, 7. Is fluorine 1, 2, 3, 4, 5, 6, 7. This is fluorine 1, 2, 3, 4, 5, 6, 7. So if you look at sulfur, sulfur have how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So which is expanded octet, which is more than 8. So it's an exception. So please, I want us to take note of that. So it's as simple as ABC. So just draw the dot and cross diagram. Each of the fluorine atoms has completed this octet state. So except sulfur, which is expanded octet. So it's an exception. So I'm going to represent it using the shells also. It's a different form of representing it using the shells to show the formation of covalent bond, whereby we use the dot and cross diagram. So I'm going to erase this and do that. So this is sulfur with 6 electrons in the outermost shell. 1, 2, 3, 4, 5, and 6. So this one will come 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's fluorine. It's fluorine. 1, 2, 3, 4, 5, 6, 7. This fluorine. 1, 2, 3, 4, 5, 6, 7. This fluorine. 1, 2, 3, 4, 5, 6, 7. This fluorine. 1, 2, 3, 4, 5, 6, 7. So this fluorine. So each of the fluorine atom has completed its octet state. While if you look at sulfur, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is expanded octet, which is more than 8. So to draw the display formula, it will be like this: fluorine, 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 fluorine. So that is that. So it's as simple as A, B, C. So you can use any form of representation to represent it. So please, I want us to take note of that. These are just few exceptions that deviate from the octet rule during the formation of covalent bond. So it's as simple as A, B, C. So we want to look at the dot and cross diagram of oxygen molecule. Oxygen is a covalent molecule. The formation of covalent bond in oxygen molecule is between atoms of the same element. So this is the formula for oxygen, which is one atom of oxygen plus another atom of oxygen gives you one molecule of oxygen. So let's show the dot and cross diagram. So this is oxygen. Oxygen has 6 electrons in the outermost shell. So you have 1, 2, 3, 4, then 5 and 6. Then the other oxygen will come with its own. We are using dots here. 1, 2, 3, 4. Then we'll have 5 and 6. So you can see each of them has completed its what? Octet state. They've attained the noble gas configuration. So we'll have 1, 2, 3, 4, 5, 6, 7, 8. The other oxygen has completed 1, 2, 3, 4, 5, 6, 7, 8. So if I to draw the display formula, it is oxygen, double bond, oxygen. So that means each of them contributes what 2 electrons for the bond formation. This is an example of what we call double covalent bond. So we can also represent it where we draw the shells. So we can use shells to represent it. This is one oxygen. This is another oxygen atom. So this is oxygen and this is oxygen. So this one have what 6 electrons in the outermost shell. So you have 1, 2, 3, 4, then 5 and 6. So we're using dot for this oxygen. 1, 2, 3, 4, 5 and 6. So each of them has completed what their octet state. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So each of them has completed their octet state. They have attained the noble gas configuration. So this is an example of a double covalent bond, whereby each of the atoms contributes 2 electrons for the bond formation. The double bond is an indication that each oxygen atom contributes 2 electrons for the bond formation. So it's as simple as what? A, B, C. So we want to look at the dot and cross diagram of carbon dioxide molecule. Carbon dioxide is a covalent molecule, so we are looking at the formation of covalent bond in carbon dioxide molecule. Now, the formation of covalent bond in carbon dioxide molecule is between atoms of different elements. Formation of covalent bond in atoms of different elements, because carbon dioxide contains 1 atom of carbon and 2 atoms of oxygen. So we're going to use the dot and cross diagram. So this is carbon dioxide, which is CO2. So if you look at carbon is the central atom. So carbon have 4 electrons in the outermost shell. So have 1, 2, then 3 and 4. Then oxygen has 6 electrons in the outermost shell. So we are using dot for oxygen. So you have 1, 2, 3, 4, 5, and 6. Then the other oxygen will come with its own 1, 2, 3, 4, 5, and 6. So you can see each of the atoms has completed its octet. The oxygen has completed 1, 2, 3, 4, 5, 6, 7, 8. Carbon has completed 1, 2, 3, 4, 5, 6, 7, 8. The oxygen has completed, the other oxygen has completed 1, 2, 3, 4, 5, 6, 7, 8. So each of the atoms has completed its octet state. They have attained the noble gas configuration. So if I to draw the display formula, we'll have oxygen, double bond what? Carbon, double bond oxygen. So this is an indication that each of them contribute 2 electrons for the bond formation. This is an example of what we call a double covalent bond. So we can also use shells to represent the dot and cross diagram. You can draw the shells this way. You can decide to do it this way. This is carbon. This is oxygen. And this is oxygen. So you can see that carbon has 2 electrons in the outermost shell. So carbon contains 4 electrons in the outermost shell. So we'll have 1, 2, 3, and 4. Oxygen contains 6 electrons in the outermost shell. So we'll have use the dot 1, 2, 3, 4, then 5 and 6. So we'll do the dot here. This oxygen contributes 1, 2, 3, 4, 5, and 6. So if you look at carbon, carbon have 1, 2, 3, 4, 5, 6, 7, 8. This carbon have 1, 2, 3, 4, 5, 6, 7, 8. Oxygen have 1, 2, 3, 4, 5, 6, 7, 8. This oxygen have 1, 2, 3, 4, 5, 6, 7, 8. So each of them has completed their octet state. They have attained the noble gas configuration. So this is a way of drawing the dot and cross diagram. We make use of what? The shells. Use the shells to show the dot and cross diagram. So you can see each of the atoms are attain their noble gas configuration. So this is how you can draw the dot and cross diagram of carbon dioxide molecule. So showing the formation of what? Covalent bond, the carbon dioxide molecule. So I want to look at the dot and cross diagram of ethane molecule. Ethane is a covalent molecule, which is also a hydrocarbon. So I want to use the dot and cross diagram to represent covalent bond in ethane. Now the formation of covalent bond in ethane is between atoms of different elements. Ethane contains 2 atoms of carbon and 4 atoms of hydrogen. So this is the formula for ethane, which is C. This is the formula for ethane, C2H4. Yes, ethane is C2H4. It's a hydrocarbon. It's an unsaturated hydrocarbon. So we want to represent covalent bond ethane using the dot and cross diagram. So if you look at carbon, carbon have 4 electrons in this outermost shell. So we'll have 1, 2, 3, and 4. Then the other carbon also have 4 electrons in its outermost shell. So we'll have 1, 2, 3, and 4. The hydrogen will share with carbon, share its 1 electron with carbon. Hydrogen will also share its 1 electron with carbon. Hydrogen will share its 1 electron with carbon. This hydrogen will also pair up with carbon and share its 1 electron. This hydrogen will also pair up with carbon and share its 1 electron. So you can see that each of the atoms has attained its noble gas configuration. Carbon has completed 1, 2, 3, 4, 5, 6, 7, 8. It has completed its octet state. This carbon has completed 1, 2, 3, 4, 5, 6, 7, 8. The hydrogen has completed 1, 2, 1, 2, 1, 2, 1, 2. It has completed its duplet state. So if we are to draw the display formula, we'll have carbon, double bond carbon, single bond hydrogen, single bond hydrogen, single bond hydrogen, single bond hydrogen. The single bond is an indication that carbon contributes 1, hydrogen contributes 1. Then the double bond between carbon to carbon means that each of the carbon atoms contributes 2 electrons for the bond formation. So this is an example of what we call double covalent bond. In double covalent bond, each of the atoms contributes 2 electrons for the bond formation. So it's as simple as ABC. We can also draw it using the shares. It's as simple as ABC. Just draw shares, then you use the dot and cross diagram to represent it. So it's as simple as ABC. So this is just the formation of what covalent bond in ethane molecule. I told you the essence of bonding is for them to attain the noble gas what configuration, each of the atom to attain its octet or what duplexes. So it's as simple as ABC. So we want to look at the dot and cross diagram of nitrogen molecule. Nitrogen is a covalent molecule which is formed as a result of covalent bonding. Now the formation of covalent bond in nitrogen molecule has to do with what? Atoms of the same element. In the formation of covalent bond in nitrogen molecule is between atoms of the same element. So this is the formula for nitrogen. One atom of nitrogen plus one atom of nitrogen, you get one molecule of nitrogen. So if we are to draw the dot and cross diagram, so this is nitrogen. Nitrogen has 5 electrons in the atom shell. So we use the cross for the first nitrogen atom. 1, 2, we have 3, 4, and 5. Then the next nitrogen atom, 5 electrons in the atom shell. So we are using dot here. 1, 2, 3, 4, and 5. So you can see that each of the nitrogen atom has attained its noble gas configuration. Each of the nitrogen atom has attained its octet state. So this nitrogen you have 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen you have 1, 2, 3, 4, 5, 6, 7, 8. So each of the nitrogen atom contributes 3 electrons for the bond formation. So if we are to draw the display formula, it's going to be nitrogen triple bond nitrogen. This is an example of triple covalent bond. So each of the atom contributes 3 electrons for the bond formation. So this is an example of what? Triple covalent bond. We can also represent it using the shares, whereby we draw the shares and we represent the electrons using the dot and cross diagram. I have to erase this and represent it using the shares. So this is nitrogen, 5 electrons in the outermost shell. So you have 1, 2, 3, 4, and 5. So the other nitrogen will come. We share with this. Let me erase this so that I can draw it properly. Nitrogen, you have 1, 2, 3, 4, and 5. Then the other nitrogen will come and share. We are using dots for the other nitrogen. 1, 2, 3, 4, and 5. So each of the nitrogen atoms contribute 3 electrons for the bond formation. So each of the nitrogen atoms has attained its octet state. So you have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the display formula will be nitrogen triple bond nitrogen, which is an indication that each of the nitrogen atoms contribute 3 electrons for the bond formation. So this is the formation of nitrogen molecule as a covalent compound using the dot and cross diagram. So it's as simple as ABC. So we want to look at the formation of covalent bond in ethane molecule. Ethane is a covalent molecule. Ethane contains 2 atoms of carbon and 2 atoms of hydrogen. So the formation of covalent bond in ethane is between atoms of different elements. So we want to use the dot and cross diagram. Now this is the formula for ethane. Ethane is C2H2. So if we are to draw the dot and cross diagram, this is carbon. Carbon have 4 electrons in its outermost shell. So you have 1, 2, 3, and 4. Then the other carbon also has 4 electrons in its outermost shell. So you have 1, 2, 3, and 4. So hydrogen will pair. Hydrogen will share 1 with carbon. This 1 electron with carbon. We are using dot for hydrogen. Hydrogen will also come and pair up with carbon. Shares 1 electron with carbon. So you can see each of the atoms has attained its octet. Each of the atom has attained its noble gas configuration. Carbon has attained the octet state, which is 1, 2, 3, 4, 5, 6, 7, 8. This carbon has attained 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen has attained its duplex state 1, 2. This hydrogen 1, 2. So each of the atoms has attained what is noble gas configuration, which is the essence of bonding. So if we are to draw the display formula, it will be what? It will be carbon, triple bond carbon, single bond hydrogen, single bond hydrogen. The triple bond is an indication that each of the carbon atom contribute 3 electrons for the bond formation, while the single bond is an indication that each of the atom contribute 1 electron for the bond formation. Carbon contribute 1, hydrogen contribute 1. That's why we have the single bond here. This carbon contributes 1 electron, hydrogen also contribute 1. We'll have a single bond here. We'll have a triple bond here. Carbon contribute 3, the other carbon contributes 1, 3. This is an example of what we call a triple covalent bond. We can also use shares to represent it. So we just draw the shares. It's the same pattern, the same method. So it's as simple as what? As A, B, C. So this is how to use the dot and cross diagram, to represent the formation of covalent bond in ethyne molecule, which is an example of a triple covalent bond. So this is the display formula. So I want to look at the properties of covalent compounds, which are characteristics of covalent compounds. The first one is they exist as gases, liquids, or soft solid. They are usually gases or volatile liquids. The number 2, they have low melting point and low boiling point. Yes, the melting point and boiling point of covalent compounds are generally low. And the reason is because the molecules are held together by weak intermolecular forces of attraction, which are basically van der Waals forces. Then number 3, they're insoluble in water but soluble in organic solvent. They're insoluble in water, they're insoluble in polar solvent, but soluble in non-polar solvent, which are organic solvent. They're examples of non-polar solvent. Then number 4, they are non-conductors of electricity in solid, molten, or aqueous state. They don't conduct electricity. Then they exist as molecules. Generally, they exist as molecules. So these are the characteristics of covalent compounds or properties of covalent compounds. Thank you for listening. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, share, like, and comment. I'm Mr. Joe, your chemistry teacher. Once more, thank you for listening. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.